So we started out in lesson 1 looking at relative velocity or relative speed. How do I know I'm doing that? Oh, there's two objects moving at different speeds. So, we have to do my favorite student, good old Anne. Sorry for those of you on YouTube, I'm fighting a cold. A rabbit is running away at 24 meters per second from a wolf that's going 32 meters per second. What's the speed of the rabbit relative to the wolf? You could say -8 or +8. I'm not going to be fussy, but it's 8 meters. I said speed, so it's 8 meters per second. Is that not right? Yes? Okay. That's the difference in speed. What that really means is if I want to analyze this mathematically, I can pretend that the rabbit is at rest and the wolf is traveling forwards at 8 meters per second. Or I can pretend that the wolf is at rest and the rabbit is traveling backwards at 8 meters per second. I'd probably use the first option. If the rabbit has a 12-meter head start, how long will it take? Okay, this is asking me to find t. Looks like we have to travel a distance of 12 meters. We have a speed, a relative speed, of 8 meters per second. What did I say acceleration was going to be for this whole unit? Yeah, so if I'm using a distance equation, it's just going to be d equals vt plus a half a. No, a is 0. It's just going to be that. So this one wants us to find time. Time is going to be distance divided by speed. It's going to be 12 divided by 8. It's going to, is it 1.5? Seconds. If you got that 2 out of 2, otherwise I would probably give you a half mark for the relative velocity, 1 whole mark for that equation, and then a half mark for the answer. Please, how many marks is this one worth? How many marks is this one worth? Probably means more than 1 step. Might even mean more than 2 steps. We'll see. Gotta blow my nose. I apologize again. Yuck. Police are chasing a car which is 180... Oh. Okay, it looks like they want me to find V. I can't. What I can find is the relative speed. How much faster the police have to be going than the bad guys. I'll let the bad guys be going 0. The distance the police have to catch up is 180 meters, and they got to do it in 4.8 seconds. I can use D equals VT. I can use V equals D over T. It's going to be 180 divided by 4.8. 180 divided by 4.8. They've got to go 37.5 meters per second. Relative to the bad guys. That means if the bad guys are going 10 meters per second, these police need to go 47.5 meters per second. If the bad guys are going 20 meters per second, police have to go 57.5. They have to go that much faster than the bad guys. Now it wants the velocity in kilometers per hour, so the first thing I'm going to do is I'm going to turn V relative into kilometers per hour, so it's 37.5 meters per second. Is it times by 3.6? I think it's times by 3.6. Yes? They have to be going 135 kilometers per hour faster than the bad guys. How fast are the bad guys going, Brady? So, V is going to be 160 plus 135. Police are really going to have to be moving. I don't know if they can actually go this fast. Maybe some of the... Because the police cars tend to have different transmissions and different engines. And a lot of modern cars have what's called a governor, which tops out your top speed. And police cars usually have those removed, so they can go really fast. Is it 290? Yeah. 295? Yeah? Is that what you're saying? That's what I meant to say? 295? Yeah? If you got that, 3 out of 3. By the way, there's a few ways to get this answer. I found relative speed first, converted it to kilometers per hour, and then got the answer. You could have converted all the kilometers per hour to meters per second and gotten an answer. You could have, once you found this, there's several ways to get this. First, if you have the right answer, 3 out of 3. Otherwise, I would probably give you 1 mark if I saw that, 1 mark if I saw that, and then 1 mark for the answer. Question 3. Oh, now we're talking spaceship and relative speeds. Now we're going to use special relativity. They want us to find t. Well, I think t equals t0 all over the square root of 1 minus v over c all squared. I showed you, for those of you that were away, we said that that's also called the Lorentz factor, the gamma function, and it's less writing. So it's going to be 8 years on the ship, square root of 1 minus 0.99 c over c all squared. Evan, do I see? I do see this time. So it's going to end up being, I'm going to try typing this in one step now. I've gotten pretty good at this. If you want to experiment with your calculator and, Emily, see how much you can do in one fell swoop, go right ahead. I can go 8 divided by square root bracket 1 minus 0.99 squared. That's how I would type that in if I wanted to do it in one step. And I get 56.7, yes? 56.7 years back home on Earth. If you got that, 2 out of 2. Otherwise, I would probably give you half mark for that, 1 mark for that, half mark for the answer. What's the trickiest part with relativity, Morgan? Number one, calculator typing. We're doing some heavy-duty math, but honestly, it's remembering which one is the zero term and which one is the non-zero. And we noticed last lesson it switched a bit for length, and it'll switch a bit for mass too. Sorry. Spaceship Travels. How much time will pass on Earth? This is really the same question as number 3. I don't know why I asked it twice, but okay. T equals t0 all over the square root of 1 minus v over c all squared. Or I could have written t equals t0 over gamma. It's going to be 12 all over 1 minus 0.96 c, 96% of the speed of light. It's going to be 12 all over the square root of bracket 1 minus 0.96 squared. You get 42.9 years, 43 years. I'll go 3 sig figs. 42.9 years. Same marking as before. I would give you half mark for the equation, 1 mark for getting the numbers in the right place, and a half mark for the answer. Now, in number 5, they want me to find time on the spaceship. They want me to find time on board. I think that equation, if I rewrite it, ends up being t times the square root thingy, times the gamma function. It ends up being time back on Earth, 16, times the square root of 1 minus 0.99 c over c all squared. It ends up, oh, do you see? Do you see? I do see. It ends up being 16 times the square root of bracket 1 minus 0.99 squared. By the way, is the answer here going to be more than 16 or less than 16? Does time move faster or slower on the spaceship? Which one? Slower. I know ahead of time, if I get an answer bigger than 16, I've messed up. Slower. Only 2.25, 2.26. Really 2.3, I should really only go to 2 sig figs and 2 sig figs. Half mark, 1 mark, half mark. How much time has passed on the spaceship? That, again, wants us to find time on board, which is going to be t times the gamma function. It's going to be 15 Earth years, 1 minus 0.995 c, 99.5% of the speed of light. So it's going to be 15 times square root bracket 1 minus 0.995 squared. Do you get 1.5 years? That's almost a 10 to 1 relationship right there. If you're going 99.5% of the speed of light, time is passing 10 times slower for you on the spaceship than back home on Earth, because 15, 1.5. It's almost bang on at 10 to 1. Next page over. So here are the two speed questions. I wrote in brackets, this is a tough one you were solving for V, because I used to actually make the kids derive the V equation, and I had mercy last year because it was a bear to get the V by itself. You had to get it outside of a square root. How do you get rid of a square root? Square everything. And you had to do FOIL and... I've never memorized this equation. I know they're asking me to find V. What is the V equation from our green sheet? I know it's V equals C square root. It's T0 over T all squared? Okay. And you may notice the V equation for length, I think, has the L0 on the bottom. And it's easy to get these mixed up. Mackenzie, all I can say is when you're done yawning, read really, really carefully. Okay? They want this as a percentage of C, so I'm just going to leave the C kicking around. It's going to be 1 minus time on the spaceship, 8 over time back on Earth, 100 squared. It's going to be the square root of 1 minus 8 divided by 100 in brackets squared. If you wanted to type that in one fell swoop, Justin, that's how I would probably do it. And again, some of you that have the newer ones, the Casios with the orange buttons and things, I think it does the brackets and the indentation for you automatically, which makes it easier for you to type these in one fell swoop. Do you get 99 point what? Is it a 6? What's next to the 6? So I'm going to go to 4 sig figs. I'm going to go 99.68% of C. Now, here's what I wouldn't take. Don't round that off to 100. Because if you're telling me it's 100% of the speed of light, can't go that fast. So 99.7 I would take. 99.6, I'm taking a half mark off, and I'm saying learn to round off properly. 99.68% I would take. 99 point, you know what, that's a nice place to round because there's a 9 right there, so that's probably a good place to round. For 3 marks, that gets you 3 out of 3. I'll probably make that worth 2 marks next year because I gave you the equation this time. It used to be, had to derive the equation. So how would I give this? I guess 1 mark for the equation, 1 mark for the numbers, 1 mark for the answer. Number 8 says, same idea, but this time instead of leaving your answer as a percentage, give it to me in meters per second. Again, I'm going to go, the speed that I need to travel is equal to C times the square root of 1 minus T0 over T all squared. The speed is going to be C square root of 1 minus 20 over 1,000 all squared. The square root of 1 minus bracket 20 over 1,000 close bracket all squared close bracket. We're going to have to travel at 99.98% of the speed of light. But if I multiply that by what C actually is, in meters per second, it ends up being 2.9994. I'll go 2.999. If you put the 4 in, that's okay as well. Meters per second. Just shy of the speed of light. 1 mark for that. 1 mark for that. 1 mark for the answer. Can you give yourself a lovely score on this out of, what's this quiz out of? 20, please. Did I do 10? Did I forget the times 10 to the? Yeah, you know what? That's a little slow. Thank you. Candy for you. Times 10 to the 8th meters per second. Let's try that again. Give yourself a lovely score out of 20. Pause the video. So last day, we started talking about the length equation. This is for those of you that were away. It's on your green sheet. We said that length is contracted in the direction of travel. In other words, if this piece of paper went zipping by you to your, what direction is that for you, right? Went zipping past you to your right at near light speed, it wouldn't shrink vertically at all, it would shrink horizontally. You would see the piece of paper maybe only seeming about this long. Same width, but the length gets contracted. And if you're the object that's traveling, you see all of space-time contracted in the direction of travel. That's why those spaceships got different answers for the number of light years to the nearest star or planet. It's because space-time itself actually does contract in the direction of travel. Gets even weirder. Sorry, that's a typo. Hang on. Stranger, cross out stranger, cooler, I think. Einstein also showed that as objects speed up, there is an increase in mass. This mass is actually appearing in the form of energy. From this equation, if you're clever, you can also end up with E equals mc squared, which we're not going to get into, but that's one of Einstein's famous equation. It's governed by this equation here, m equals m0. Well, you know what? You can also write it this way. M equals m0 over the Lorentz factor, that gamma function. This one, I think, looks very similar to the time equation. And the time equation is t0 on top of the square root on your green sheet. I think, yeah? Okay. So, where m0 is the original mass at rest, L0 was the original length at rest. Unfortunately, T0 is not the time at rest. T0 is the time on board the spaceship. I know it seems inconsistent. It's not. If you dive into relativity, it eventually does make sense. But for now, Morgan, I'm going to say just kind of keep them straight. Oh, and M is the moving mass. Fancy word, the relativistic mass. So, suppose you had an object that was 10 kilograms. How big is 10 kilograms? Pretty much this thing right there. All right? Suppose you've got an object that's 10 kilograms and you're going to get it moving. You're going to attach a rocket to it or something. What would its mass become if it was traveling at a speed of 2.5 times 10 to the 8th? What's this question asking me to find? A mass? Yeah, original mass or relativistic moving mass? Moving, so M or M0? M. So we're going to go M equals M0 over, and I got lazy. I put the gamma symbol, square root of 1 minus V over C. All right. What's the original mass? 10 divided by the square root of 1 minus. Did I give you the speed as a percentage of light this time? Because I'll have to put the 3 times 10 to the 8th in for C. So it's going to be 2.5 times 10 to the 8th all over 3 times 10 to the 8th squared. And then what's that all inside of, Faith? Square root? Okay. Mr. Dewitt, can you type that in one step? It gets a bit complicated. I could, but I'd probably lose track of brackets. I'm going to start on the bottom bracket and Emily just work my way out. So I'm going to go 2.5 scientific notation button 8 divided by 3 scientific notation button 8. We're going 83% of the speed of light. Squared. 1 minus that. Square root of that. 10 divided by that. What do you get? What'd you get? It's an error. Okay? So this is also worth where you practice along. Don't clear it. Did you clear it? Next time don't, because usually you can backspace and it'll put you where the error is next time. You get a little less than 20, don't you? 18 something? 18.1? Yeah. What if we get this 10 kilograms 98% of the speed of light? Oh, this time I gave it to you as a percent. So do you see? Do you see? We can see. The mass is going to be, the original mass is 10 kilograms, square root of 1 minus 0.98 c over c. Don't forget the squared. Ibrahim, do you see? Do you see? Do you see? Good. I'll try doing this. 10 divided by square root bracket 1 minus 0.98 squared. I think I typed that right. I have the answers here. I think a little over 50. Work this time? Yeah. Okay, so you probably just made a typo in the previous one. 50.3. So 98% of the speed of light. Already we've increased the mass by 5 times. You spotting the trend? The faster you go, Chantel, what happens to the mass? It gets bigger and bigger and bigger. And here's the problem. I don't know why I suddenly switched to black. Let's go back to red. The more the mass, the more energy you need to get it to go faster. What if we want it to go 99% of the speed of light? Well, that's going to be m equals 10 all over the square root of 1 minus 0.99 c over c all squared. C's cancel. What do you get? Can I go 70.9? So this 10 kilogram mass, starting at rest, now has 70.9 kilograms of mass. The fastest we can get anything right now is in the Large Hadron Collider. We can get protons in the Large Hadron Collider at 0.1234567 nines and then a 1 of c. It's 2.7 meters per second slower than a beam of light. In other words, if a beam of light and the protons had a race for 1 second, at the end of that 1 second, the protons would be about this far behind the beam of light, 2.7 meters. Pretty fast. Alrighty. What will this 10 kilogram mass? 1 minus 0.12345 nines. 1, 2, 3, 4, 5, 6, 7, 8 nines, and then a 1. C over C all squared. Come on, you want to type this in. Have you already, Ibrahim? It's a pretty staggering answer. More than 1,000 kilograms? 8 nines. And then a 1. More than 1,000 kilograms? Oh, yeah. More than 10,000 kilograms? More than 50,000 kilograms? It's in the 70s, yeah? You get 74,535.6. You know what? You get a lot. And this, Dom, is another reason why we can't get objects with matter, with mass, to hit light speed. What if you try putting in the speed of light into this equation? What do you get? Well, let's see. Then your C would cancel. You get 1 minus 1. What What's 1 take away 1? 0. So what's the square root of 0? So you'll divide by 0. What do you get when you divide by 0? Error. Yeah, the fact that you can't divide by 0 is one of the reasons we can't get to light speed. Now, if you take calculus next year, you'll learn actually it approaches infinity. So if you wanted to get a proton to light speed, its mass would essentially become infinite. You know how much energy that takes? More than there is in the universe. That's why you can't go hit the speed of light. Light really is the cosmic speed limit. So what's your homework? I already said you could try 1, 2, 3, 4, 5, 6, 7, 8, but now you can also try the ones that involve mass. So 9, 10, 11, 12, 13, 14, 15. I'm going to assign all of them 16, 17, and 18. I've put an answer key showing all my steps online for the time dilation one. It's under block, G. It's there. And I'll put one online. I did attach the answers, but if you were wondering how I got the answers, I'll throw an answer key online as well. You have time now to work on the homework, but I also have some cool, crazy videos to show you.